Good evening, everyone. Today's class, we're going to see the chapter number 8, which is applications of integrals. This comes after integration. So here we need to draw a rough diagram of the area that we are finding and find that area using integration. So there are certain shapes for which we need to know their areas. This was done in last year's conics, so let's brush up those formulas and the equations once again. Conics, first one is a circle. Under circle, there are two types of equations. Equation of circle with center 0, 0 and radius r, which is x square plus y square equals to r square. Next one, equation of circle with center h, k and radius r. So their equation will be x minus h the whole square plus y minus k the whole square equals to r square, where h and k represents the center. Next is a parabola. There are four types of parabola. The one that is open towards the right side look like this, and the equation is y square equal to 4ax. The one that opens to the left side will look like this. Equation is y square equals to minus 4ax. The one that is open upwards will look like this, and equation is x square equal to 4ay. The one that opens downwards will look like this. Equation is x square equal to minus 4ay. Ellipse. There are two types of ellipse, one on x-axis and the other one which is on the y-axis. To identify which type of ellipse is given in the question, just understand that in ellipse A is always greater than B. So if the greatest value is lying under x, then it is the first type of ellipse, that is the x with the major axis on x-axis. And if the larger value lie under y, the largest number out of the two lying under y, then it is the second type of an ellipse where the major axis is the y-axis. Hyperbola, mainly we won't get questions based on hyperbola, but just for understanding I've covered that also. Hyperbola, two types, one opening left and right and the other one opening up and down. Here, to identify which type of hyperbola it is, if x is positive, it's the first type. If x-axis is negative, if x is negative, it's the second type. A and B will never change its places here. The first denominator will be A, the second denominator will be B. The A and B will not change its places. Only x positive, x negative will decide which type of hyperbola we are dealing with. The next, the area bounded by the curve. So far we discussed different types of conics. Now we are going to find the area bounded by the curves with x-axis and with y-axis. Mainly the questions will be focusing on x-axis, but there are questions with y-axis also. Whether you do it for x or whether you do it for y, the answer remains the same. But more often x-axis will be easier to deal with than the y-axis way. So when you find area with respect to x-axis, it is integration of y dx, limit a to b. Now y means you change the question y in terms of x. So an equation will have an x and y as its variable. You put y on one side and put all the other terms to the other side. Take all the other terms to the other side. So express y in terms of x and replace y with that. And then start integrating. So area bounded by the curve with x-axis will be integration of a to b y dx. This is how the area will look like. It's a curve, a rough curve where it meets the x-axis at b and a. So the area bounded by the curve with x-axis will be this region. Next, area bounded by the curve with the y-axis. So if it's y-axis, the curve would be like this, and the limits will be where it meets y-axis is a and b. So instead of y dx here, it will be x dy. So you put x to one side and all the other terms to the other side. So x on the left side and the rest of the terms on the right side of the equation. And you change this x in terms of y. Start integrating, apply the limit, you get the answer for that. The third type of questions is area bounded by the two curves. Area bounded by the two curves can be two-way, one upper and one lower. Like you see here, it could be upper and then lower. So here it is upper curve area will be this region. The upper curve area will be this region, whereas the lower curve area will be this region. So upper curve minus lower curve will give you area bounded by the both. So here area bounded will be g of x minus f of x, because they've given a name to each of the curve. The upper curve is named as g of x, the lower curve is named as f of x. So g of x minus f of x. The point where the curve meets is the B and A limit. Second type is when the area bounded by the two curves, but the curves looks like this. It look like this, like it's like this. So then it is integrating one curve with the limit a b to c, then integrating the other curve with limit c to a. It comes like adjacent to each other, so we add the area here. The limits are identified by solving the equations. The limits are identified by solving the equations. So yes, let's start with the first sum of the exercise 8.1. Find the area of the region bounded by the curve y square equals to x and the lines x equal to 1 and x equal to 4 x-axis in the first quadrant. This is an added line in some of the books, in some editions of the NCERT textbook, but in some book it's not there. So here I'm doing it for first quadrant. Area bounded by the curves and the lines with the x-axis inside the first quadrant only. Right. So here y square equal to x is a parabola that opens to the right side. So this is the main shape. So first step is to draw the parabola. And the next they said find the area bounded by the curve and the two lines. The two lines are x equal to 1 and x equal to 4. Now remember to verify whether the lines are actually meeting the curve or not. Sometimes when you apply the x value in the curve's equation, you might get unreal values for y, imaginary values. In that case, we will drop it and we'll say that the line in the curve is not meeting there. So there would be some other ways to sort it out. But it is must to check whether it meets or not. So when x is 1, y square equals to 1 because y square equals to x. So the point of intersection would be 1 comma 1 and 1 comma minus 1. Likewise, when x is 4, y is plus or minus 2. So the meeting point would be 4 comma 2 and 4 comma minus 2. So x is equal to 1 meets the curve at 1 comma minus 1 and 1 comma 1. X is equal to 4 meets the curve at 4 comma minus 2 and 4 comma 2. Now here it is restricted to area bounded to the first quadrant alone. So integrate the curve with limit at a point where it cuts the x-axis. It cuts the x-axis at 4 and 1. So you do it for 4 and 1. So integrate x-axis, formula is integration 0 a to b y dx. Y here is root x because y square equal to x. So y equals to root x. So in the place of y we substitute root x, then integrate it, apply the upper limit and the lower limit, get the area. So this would be the area for the first question. Whereas for the next one, it is area bounded by y square equals to 9x with the line x equal to 4 and x equal to 2. Now y square equal to 9x is also a parabola that opens to the right side. The lines are x equal to 2 and x equal to 4. So 4 here and 2. Again, the area would be only with respect to x-axis and that too in the first quadrant. So this is the area that we intend to find. So it's the same thing. Y square equal to y square equal to 9x. So what is y? Y is equal to root over 9x. So y is equal to root x into 3. Root x into 3. So root x will be integrated, 3 will be taken out of integration. Limit will be 2 to 4. Integrate and apply the limit value. If there is any doubt in simplifying 4 power 3 by 2, turn it over here. 4 power 3 by 2 is 4 cube to the power of 1 by 2. 4 cube is 4 into 4 into 4, and then the square root of that. So 4 2 times makes 4 square, and root of 4 square is 4. Then a root 4. So it's 4 into 2. That's why we get 8. Likewise, 2 power 3 by 2 is 2 cube the whole root. 2 square will come out as 2 out of the root. Then it will be 2 root 2. So this is the answer for the second one. So third one is also similar. Question number 4. Find the area enclosed by the ellipse with x-axis. Equation of the ellipse is given as x square by 16 plus y square by 9 equals to 1. So this is a type 1 ellipse because 16 is greater than 9. I told you in order to identify the ellipse, the type of ellipse, that check for the greatest value. If the greatest value out of the denominator lies under the x, then it is the type 1, and if it lies under the y, it is the second type. So this is the horizontal ellipse where the major axis is x-axis, so type 1. So the main diagram is drawn. Then its area bounded by the enclosed by the ellipse. So where it meets the x-axis would be a and b. So standard form is this. So meaning a square is 16 and b square is 9. If a square is 16, a is plus or minus 4 and b is plus or minus 3. We generally keep a and b in positive form, though we plot the negative values. So a is 4, b is 3, and then when a, similarly minus 3 for b and minus 4. Now if I find the area for the first quadrant and then multiply it by 4, it's enough to find the area of the ellipse. So area equals to, I'm doing it for x-axis, so therefore integration a to b y dx. And the equation here is the equation of ellipse. So I have taken the general equation and transformed that y in terms of x, like transformed it such a way that y is in terms of x. The transformation is shown over here. So this is for the general form. You can even take the one that is given in the question and transform that. The transformation is simple only. Y square by b square equals 1 minus x square by a square. Take LCM, you get a square minus x square by a square. Then take the b square to this side, just focusing on keeping y on one side, rest of the terms on the other side. So since it's y square, you get a root over here. So this would be b by a root over a square minus x square. And according to our question, b is 3 and a is 4. So it will become y is equal to 3 by 4 root over 4 square minus x square. So integration will be integration will be 4 into 3 by 4, 0 to 4 root over 16 minus x square. This is what we get. Now root over 16 minus x square is in the form of root over a square minus x square. The formula to integrate root over a square minus x square is over here. So integrate this using this. Wherever there is a, substitute 4. Wherever there is a square, substitute 16. So this way we get the answer like this. Then apply the upper limit and the lower limit. So upper limit will be, this one is, upper limit is 4 and the lower limit is 0. So when you apply the lower limit, upper limit, we get everything becomes 0 except there is a sine inverse 1. Sine inverse 1 is sine inverse of sine pi by 2, which is pi by 2. Multiply with the rest of the numbers, you get 12 pi as the answer. Whereas the lower limit will give you only 0, since it doesn't matter to show that. And here, this is basically the formula. So no need to write 16, it's in the formula form. So it's a square minus x square, a square by 2 into sine inverse of x. Question number 6. Find the area of the region in the first quadrant enclosed by the x-axis. The line x equal to root 3y and the circle x square plus y square equals to 4. So equation of circle is x square plus y square equals to 4. And equation of line is x is equal to root 3y. The root is only for 3, not for y. And it is only in the first quadrant. So area enclosed by the x-axis, circle and x equal to root 3y line in the first quadrant. So now the main figure here is the circle. So let's draw a circle with center 0, 0, radius 4. Radius r square equals to, so it's x square plus y square equals to r square. So r square is equal to 4 implies r equal to 2. So this is 2, 0 coordinate. Now it's the area enclosed by the line and the paired circle. The line here is x is equal to root 3y. Remember, whenever there is no constant in the line's equation, the line will pass through the origin. So when, see, if an equation is ax plus by plus c equal to 0, and if c is not there, if the constant is not there, then the line will definitely pass through the origin. So the line will be either this way or it would be this way. So we just have to identify which direction this line goes. So here, rather than finding arbitrary values for x and y, let us find the point of intersection of the curve with the line. So I'm going to solve the curve equation with the line equation. So x is equal to root 3y, I'm substituting that in the equation of the curve or the circle. So x is root 3y, so that becomes substituting 2 and 1, I get root 3y the whole square plus y square equals to 4. So that is 3y square plus y square equal to 4. So 4y square equal to 4. Y equals to plus or minus 1. So that means when y is 1, x will be root 3 because x is equal to root 3y. And when y is minus 1, x is equal to minus root 3. So that means the line is meeting the circle at root 3, 1 and minus root 3, 1. And this root 3, 1 and minus root 3, 1 is the passing through point of the line also. So the line is traveling in such a way, it passes through the first quadrant and the third quadrant. So the line's direction will be, so this is the line root 3y. It meets the circle at this point, and here I'm only bothered about the x coordinate, so I'm naming this as root 3, and over here it is minus root 3, which I'm not concerned because I want to cover only the first quadrant. So now the area enclosed by the line, the circle and the x-axis would be this region. But this region is broadly divided by two regions. It is broadly made by two regions. One, well, I'll show you that. Let's shade one region in one color. Let's shade the other region in some other color. So the region enclosed will be made by two shapes. One is part of a circle and one is part of a straight line. So one looks like a triangle, the other looks like a sector or something. Okay, so now I'll tell you. Area will be, let me clear this. Area equals to integration of, I'm going to integrate the circle or the arc with limit 0 to root 3. Then I'm going to integrate the line with limit, 2 to root 3. Then integrate the line with limit root 3 to 0. I'm repeating this. I'm integrating the curve or the circle with limit 2 to root 3 and then integrating the line with limit root 3 to 0. So it will be the circle. So I'm just writing in the simpler terms. Integration of circle, which means the equation of circle, upper limit 2, lower limit root 3, plus integration of the line segment, which means the equation of the line in terms of x or y as you want, upper limit root 3 and lower limit 1. Now since I'm doing it for x-axis, it will be dx here, isn't it? So equation of circle is x square plus y square equals to 4. So y will be root over 4 minus x square. Equation of line is x is equal to root 3y. So y will be x by root 3 here. So area will be integration root 3 to 2 root over 4 minus x square dx plus integration of x by root 3 dx limit 0 to root 3. So once you complete the integration, you add the area, you get the answer. So here I've done the calculations as you see. I integrated the values and applied the limits, and I'm getting the answer as pi by 3. So check out the steps, you'll get the same answer. The rest of the chapters will be covered in the next video. Thank you.